Welcome to Building the Future. I'm your host, Kevin Horick. The radio and TV version of the show air in over 12 states. This includes both coasts and Silicon Valley. The show also airs in the UK, Caribbean, and Australia. For full show times, plus past episodes of the TV and radio show, please visit buildingthefutureshow.com. We just launched a free online community to connect past guests, listeners, and others. This community will allow you to network, chat on Slack, or get help with anything else, and a lot more. If you're interested in joining the community, buying some merch, sponsoring the show, or signing up for the newsletter, please go to buildingthefutureshow.com. The show is a proud media partner for the 11th Annual Media Excellence Awards, which are produced by Access Entertainment in Los Angeles, California. The Media Excellence Awards are recognized as the most influential awards show honoring innovation and leadership in all things mobile entertainment, lifestyle, and technology. For more information on how to submit to these awards, please visit mediaxawards.com. Welcome back to the show. Today we have Michael Lee. He's the founder and CEO at the Data Incubator. Michael, welcome back to the show.
Thanks so much for having me, Kevin.
Yeah, I'm excited to have you back on the show. You did the show, a year and a half or so ago, maybe longer.
Yeah.
And I thought basically, let's have you back on the show, not only because I think what you guys are doing is actually really cool and innovative. You guys have added a lot more stuff. You've grown. And I also think that the courses and the stuff you guys offer at the Data Incubator are so much more kind of in the public eye lately, kind of. And so I wanted to kind of bring people's attention back to what you guys are doing. So, thanks again for doing this. I really appreciate it.
Yeah, no, thank you so much. I think there's been a greater role for technology, whether that be big data, AI, or blockchain,
Sure.
entering the public sphere and the public discourse. And so as a consequence, you're getting more and more people talking about these topics, which is great for us.
Sure.
We love it when people are becoming more technically literate and taking out courses, but also I think better for society. I think that these are very important issues and topics that are coming up, and the more we discuss them, I think the better informed and the better decisions we'll make as a society.
Sure. No, I 100% agree with you. But maybe before we kind of dive a bit deeper into what you guys are doing at the Data Incubator, let's get to know you a little bit better and cover where you grew up.
Oh, yeah, absolutely. So I grew up in Portland, Oregon,
Okay.
and moved east sort of for college. So
Okay.
went to Princeton for my undergrad.
What did you take there?
Computer science.
Okay. And what was there like a defining moment in your childhood, or what got you interested in kind of taking computer science?
Yeah, so, as a kid on the West Coast who grew up in the 90s, I think the tech boom probably had this immeasurable impact.
Okay.
At some point in middle school, we all thought that we're going to go and become millionaires by the time we were 20. And then, of
Sure.
course, the first tech bubble pops, right, in
Yeah.
2000, and those dreams have to be put on hold. But no, I mean, I think I understood from an early age the power of computing and its ability to change the world. So that was something that I've always been very excited about.
No, I think that makes a lot of sense, but keep going. So.
Yeah, so I went to Princeton, did computer science.
Okay.
Really interested in how those things kind of how computers can affect our world, but then also really saw at least at Princeton this the importance of kind of mathematics and statistics, how that can play a very important part of our society. Remember, this is the early aughts, so there's a huge interest now in sort of quants and what you can do with computers and statistics on Wall Street. So I was very interested in kind of how you combine those two things, like computation and science.
Okay.
So I did a master's in statistics at Cambridge.
Wow.
I was on a Marshall. I was fortunate enough to be sort of funded by a Marshall from the UK government there.
Wow.
Spent 2 years there, came back to Princeton, ultimately did my PhD in applied math,
Wow.
Again, trying to understand how mathematics and computation kind of can be useful, not just sort of theoretical stuff, but really applied to the real world. And then, about that time, I think, did a little bit of work in Wall Street. So the usual suspects, right? Like your JP Morgans, your DE Shaws, Bloombergs, those kind of quantity places. And then moved over really to data science. I was a data scientist in residence at Andreessen Horowitz. Actually, the first time they had that position. And then moved over to Foursquare, where I ultimately kind of headed up data science monetization, trying to really help the company make money from the fixed number of eyeballs that show up to our properties every month. And through all of that, I think I had a good deal of experience understanding, well, this is how you can apply data in the real world to accomplish an organization's goals, right? And really sort of drive the bottom line. And I knew that there were more and more companies that were looking for this and looking to embrace data. And so that's why I went and moved over, started my own company, the Data Incubator, where I'm the founder and CEO, and really kind of focusing on this is how companies need to really think about talent in this space.
Sure. No, I think that's great. And you kind of quickly just covered how, like, why you decided to kind of do it. But was there kind of like a defining moment where you were like, you know what, I just need to like set up this kind of the Data Incubator and like, why did you decide to found it instead of, trying to maybe go work somewhere else or do something, kind of different? Because I think it's super important, but I'm always kind of curious if there was like a defining moment that made you just say like, you know what, I just need to go for this.
Yeah. Look, I think I was able to see a problem in the hiring and training market as a person who was on both sides of the interviewing table, right? So as a PhD leaving academia, I could see some of the shortcomings. And then as a hiring manager trying to hire talent, I could sort of see some of the problems from the other perspective. And sort of having completed that full cycle, I started realizing, look, there's a lot of things that we can do to help smooth this process out. And that's why I started the Data Incubator. And the first thing we did was we had this fellowship program where every quarter we bring in the top 2% of the 2,000 plus applicants we get. So, it's a very, very selective program. These are all folks who have PhDs, master's degrees from places like Harvard, MIT, Caltech, Berkeley, Stanford, right? The sort of Princeton, so usual top tier institutions.
Sure.
We work with them, we train them up. The program is free for the fellows who get in. And then we work with hiring companies who are looking to hire. And the way we monetize is so we get paid a recruiting fee on the back end.
Interesting. Okay, so what types of stuff do you guys teach people during the fellowship?
Oh, that's a great question. I think the way we thought about the fellowship is that a lot of it comes from the selection, right? So we are choosing the people who have 90% of the skills that are necessary to being a data scientist. And we're not really there to do the kind of fundamental heavy lifting around statistics and probability and sort of basic programming, right? The people who are coming in already have that. But what we see is there's a systematic mismatch between the kinds of skills and technologies that people from academia know and are familiar with, and the kinds of skills and technologies that industry is demanding. So what we're trying to do is fill in that last 10%. That'll get you from, hey, all the basics and the fundamentals, the hard stuff to learn. Here's what you need to do in order to actually get a job. So it's really focused around, let's say on the programming languages side, academics tend to be on very, very old legacy technology stacks. And whether that be sort of Fortran for physicists or this funny language called IDL, which is only used by the astronomy community, they tend to sort of have a very a more dated approach to technology. And what we're saying is, look, this is just not where the industry is anymore. And what we want to do is get you caught up on some of the latest tooling. So whether that be in Python or R, whether they're talking about MapReduce or Spark, getting people using the kind of tools that they're going to be using in industry, explaining to them the new concepts and the new paradigms, how to do that, and making them so much more productive. I mean, honestly, I think a lot of the feedback we're getting from our fellows is that they feel like they used to be running with shackles on,
Right.
and now we've taken those off.
Interesting. Sure. And then obviously, like when you guys are looking to get them kind of jobs, the companies that you guys have worked with in the past basically understand the skill set that they're getting, right? Like, so it's kind of a win-win from the employee and the employer side, and for you guys, obviously, but.
Yeah, absolutely. And I think that's a lot of what we were trying to do, right? One of the pieces I have in, I think it's Fast Company. So I do a lot of sort of writing.
Sure.
And one of the pieces I wrote in Fast Company was about how companies, and particularly the HR departments of companies, are really focused on these buzzwords. So they're looking for a key set of things that people claim they know on their resumes for hiring. But that's not particularly effective. What you really need to know is whether or not people know what the ideas, the core concepts. Because if they know those kind of core ideas, then it's relatively easy for them to learn the latest technology.
Right.
Or, they may already know the latest technology, but they used a synonym for that technology as opposed to the buzzword that you know.
Right.
And so it's very easy for employers to miss good talent as they're skimming through resumes because they don't have that kind of expertise. And it's very easy for them to choose the wrong kind of talent because they oftentimes choose people who claim they know something because they once looked at it in an afternoon for fun. But when you really drill down on them, they don't actually kind of know these ideas in depth.
Sure.
So that's a lot of what we're focusing on in our selection process. And then in the training process, making sure people are completely caught up with all these different technologies so that when they go and try to get a job, they now have a good tool set that they can talk about and address.
Sure. No, that makes sense. So, and correct me if I'm wrong here, but a lot of companies that would come to, the Data Incubator is because maybe they're hiring a data scientist for the first time, or maybe they have some employees that are looking to kind of get trained. But I'm curious, though, is part of the thing that I think would make me struggle is hiring a data scientist is, yeah, sure, I don't understand, like, obviously I'm not a data scientist, so it would be really hard for me to actually hire somebody that I could verify, without somebody like you guys to say, like, yes, they really are a true data scientist. Because your point a second ago about, like, just because I, read about it online or, goofed in it for an afternoon doesn't really mean I'm a data scientist, right? And so I think bridging that gap is kind of really great that you guys are kind of doing that.
Yeah, no, thank you. Yeah, and I think that's a lot of the reason that people come to us, right?
Okay.
So half of it is half of our business comes from sort of established data science teams who are basically looking to augment their hiring pipeline. So they maybe already have 5, 10 folks, and they just need that 11th, 12th, 13th person. And then the other half of it are sort of smaller companies or even larger companies that are trying to make that first hire. And they take comfort from the fact that very established teams are working with us already, right? And are hiring from us.
Sure. So how do you work with companies if they're looking to train some of their employees?
Yeah. So basically what happened was maybe 2 years ago now, companies would come to us and say, great, we hire 2, 3, 4 folks from you a quarter. These are sort of the Fortune 500 clients that we have. But that's not enough. What we really need, right, what the company's telling us, is to take the hundreds or thousands of actuaries and statisticians and folks like this, with this kind of background, I call them proto-data scientists, and we get those proto data scientists trained up to become full-fledged data scientists. So what we did was we took our curriculum. So we have an 8-week fellowship. Each week is a module.
Okay.
We broke up all the curriculum into these individual modules, and we deliver those on site, usually in person, but we have the capability of doing live.
Okay.
Online, and but it's always live training, and doing it for companies in kind of bite-sized chunks.
Okay.
And we work with companies to figure out what their learning path is. So this is where you're starting. This is where you go. Here are the classes that don't make you retake material that you already have because you already have the prerequisites, but get you to the place where you need to go because the world is a changing place and you need to be able to make sure your talent is able to adapt to that changing business environment.
Interesting.
So that's a lot of what we've been doing. We've expanded our training modules, so we're now probably up to about 20 of them now.
Interesting.
And doing a lot of training with corporate customers, a lot obviously in banking, a lot in healthcare, and actually a reasonable amount in the government now. And so the DC area.
Okay, interesting. So you kind of touched on it, I think, but correct me if I'm wrong. What are, like, if I'm an employee and my employer's willing to train me, do I need to have certain skills to actually get you guys' help, or how does that kind of work?
Yeah, so one of the things we did as we were expanding the curriculum is we took this sort of very, very advanced curriculum that we had that was more focused on fellowship, right? So people who are already pretty skilled, and we added a bunch of prerequisite classes to it.
Okay.
So these kind of foundational courses, we found are actually some of the things that the corporate clients are actually really most in need of training on.
Okay.
And it's things like, the target audience might be an analyst, right? Somebody who is used to playing with data, but
Okay.
they're doing it in Excel. They're doing sort of fairly simplistic analyses.
Right.
And they know that their tool and their capabilities are limited, and they want to break beyond that.
Okay.
So we sort of help them start doing things automatically, automating those processes, start applying techniques that are more statistically sound, that are based on machine learning and AI, and really kind of getting them up to a more advanced level where now they're able to take some of the more advanced courses that we have in our fellowship. At the very high end, it might be things like Spark or Spark or AI or deep learning,
Okay.
right? Some of these very kind of popular, perhaps sexy topics now that people like to talk about. But, you really need to have a pretty strong background to get to those topics.
No, that makes a lot of sense. I just thought that it made sense to kind of clarify that, because I think there's a lot of people that would be like, I would love to be a data scientist, but it's not like you just start there, right? Like you need to at least understand some kind of things that may not be necessarily directly related to, just data itself, right? Never mind kind of from the programming side of it.
Yeah, that's right. I mean, I think that there's, when we talk with either potential students or sort of learning and development groups, there's a huge emphasis on what's sexy, what's hot right now, right?
Yeah.
So everyone wants to learn about, let's say, deep learning, and they want to build complex neural nets. But if you can't write a for loop to save your life, you're not going to get there.
Sure.
So, a lot of our kind of conversations with these kind of learning and development groups or sort of data groups that want to become data scientists, a lot of that is about sort of customer expectation management, like explain to them that, no, you need to eat your vegetables before you can have desserts.
Sure.
And yeah, I mean, that's just part and
Sure.
parcel of, good customer expectation management and good customer relationship building.
Sure. So you guys also offer a number of courses online. Let's maybe walk through them a little bit of like what you guys kind of cover in each one of them.
Sure. Yeah, and just to give your listeners a bit of a overview.
Sure.
I think, we started this maybe a year and a half ago, because we
Okay.
realized that, look, we have this fellowship, which is for sort of super advanced people that are trying to make that transition into data science careers. We have a sort of corporate training program, which is for entire groups within companies that are looking to skill themselves up, or sort of large corporations. But what happens if you're just an individual in a large corporation, or you're a data science group, but you're just 2 or 3 people, or you're a working professional. You don't have 8 weeks to take off to just go and do the fellowship, right?
Right.
What can you do? So we started offering these online courses. The idea is that they are kind of nighttime courses for you to that you can take while working.
Okay.
The material is spread out. So, a typical module that we may do in 1 week in sort of a corporate training or a fellowship type mode where it's, full day, 8 weeks, 40 hours, that gets spread out over 4 weeks to make it more bite-sized and manageable.
Sure. No, I think that's awesome, man. I think that's really great. So let's maybe walk through some of the courses you guys kind of offer.
Yeah, absolutely. So I think, the 2 most popular are our Data Science Foundations course.
Okay.
And that's really kind of the first entree into data science. We view it very much as sort of a prerequisite for our fellowship. In fact, a lot of the people who are looking to apply for the fellowship but think that might be a little too advanced for them, they actually end up taking this Data Science Foundations course first as kind of a prerequisite that then kind of flows naturally into the fellowship. So that's kind of what that's about. And it's really the nuts and bolts, the blocking and tackling around data science. It's how do you handle unstructured data? How do you handle, even just structured data? How do you do this in a programmatic way? How do you use tools like Python and Pandas and scikit-learn to start doing that? It starts delving into the basics of machine learning so people get their foot wet there and dip a toe in. And it kind of builds that core foundational knowledge, which is then needed to go into all sorts of other courses.
Right.
The other really popular course that people follow up with, oftentimes, right after this sort of foundations course, is the applied machine learning course. So the idea there is really to do it's the same length. Both of these are 8 weeks at night, 2 days a week. But it's really focusing in on, now that you've mastered some of these basic programming concepts, let's start getting you into learning more about how do you apply that kind of machine learning statistics in machine intelligence layer? How do you do machine learning and do it correctly so that you're learning the right kinds of signals and getting the right kind of value out of data, as opposed to overfitting or underfitting or just sort of generally building very not powerful models, right? Very weak models.
Okay.
And that's kind of a lot of what we do. We go through probably a dozen different types of machine learning models you can do. We really teach you a lot about how do you set up these training pipelines correctly, and very much focus on that machine intelligence bit.
Okay. So for
Go
people that don't maybe know exactly kind of what machine learning is, maybe do you want to just kind of quickly describe that? Because I think that's super powerful.
Yeah, no, look, machine learning is one of these really powerful techniques that I don't want to say they've come out of the academy in the last few years. They haven't. It's been something that has an ongoing topic of research for decades now. But I think there was sort of a magical moment that happened, let's say a decade ago, maybe 5 to 10 years ago, when computational power started becoming good enough, and data on humans started becoming good enough, plentiful enough, that those two kind of bits of magical sauce came together, and suddenly people saw the power of machine learning all over the place. So just as a kind of brief overview, I think of machine learning as really talking about that other branch of learning, right? So we humans, we're taught what's called deductive reasoning, the idea that you have lots of facts and you have lots of logical suppositions and you try to put those together in a logical way to draw conclusions. So the bear, let's see, polar bears are white. There's a polar bear at the zoo, therefore that polar bear at the zoo is white. That kind of deductive reasoning.
Interesting.
But what we found is that computers actually learn really well inductively. So not applying these kind of abstract logical concepts, but seeing lots of data and then pulling out the patterns that emerge from that. Now, we as humans do this all the time. This is actually almost certainly how young children are learning. They sort of observe patterns, they observe data, and then they pull out the patterns from that, and they kind of learn from that. And this is something that's what machine learning is trying to do. It is trying to synthetically recreate that process of inductive learning that we as humans naturally do. But because you're doing it through a computer, you can potentially see a lot more data than a human can ever do. And you can be potentially a lot more accurate or precise than a human could ever be.
Interesting.
And you see this all the time with, things like the Netflix recommender. I think that's always the canonical example.
Sure. That most people would have used, right? Or at least seen at some point in their life. Yeah, okay, interesting.
Yeah, exactly, right? If you have a Netflix subscription, you'll notice that they give you a recommendation of like 10 different DVDs or streaming shows to watch. And those are different and individualized for every viewer or every customer. And what they're doing is effectively pulling out the patterns from a lookalike analysis. So they're inductively learning that if we look at the movies you've watched and like, and we look at what other people have watched and like, we can see that you fit into this kind of bucket, right? You have to have this lookalike group. And these other people who have your tastes, they've also seen these 4 other movies or TV shows that you haven't seen. And they've really liked those. So because you have so many shared movie preferences, we think that those last few movies that this group has seen, that could be really useful for you. And that's kind of what, it's just one example, right, of something that would be, that you can use. Another example would be looking at what products or services people buy. And when you see on Amazon, right, a lot of people say, hey, or a lot of times after you buy a product, you'll see them say like, hey, people who bought this also bought, B, right? People who bought A also bought B. And that is based on that kind of lookalike analysis and machine learning and learning those patterns of behavior inductively that people have, that would be very hard for a single human to do, right? No single human knows the Amazon purchase history of every single product in the company's history. That's impossible. But the algorithms and the computers are able to do that and are able to give you very precise recommendations. I feel as if a human who sort of has that kind of domain expertise is there to curate and give you examples. Give you recommendations.
Sure. No, I think that's quite fascinating. You guys also offer a course on kind of artificial intelligence and TensorFlow. What exactly do you teach there? Because I think that to me is kind of very much in kind of the public eye right now.
Absolutely. So, I think that there's been a huge interest in artificial intelligence. And when people talk about artificial intelligence, at least, let's say within the public discourse, or within sort of like an within an industry context, typically what they're talking about is deep learning. So this idea that you can use neural nets, which is a specific type of machine learning that's in some sense modeled on how brains work, and that they have you can sort of structure them based on these different layers. So in a neural network, you might have 3 or 5 or 8 or 100 or 1,000 layers. And what has been really exciting, and I think Google really kind of pioneered the usage of this, was building these deep learning networks that are way deeper than the previous networks we've ever built, right? Where you might have hundreds of thousands of layers, and having the kind of computational resources available to you to be able to do that, which is a big, big challenge that we're only beginning to understand how to solve.
Sure.
And building these kind of technologies. But the results have been really amazing. I think the kind of first application of this was for image search. So if you know, like image.google.com, if you go there, you'll be able to search for images.
Yep.
What they found was that by applying a neural network, they were able to get something like 5 or 10 years worth of progress.
Wow.
With one model, right?
Wow.
Compared to what they used to do, compared to previous techniques. And it was kind of a big game changer. I think they sort of realized this, and they've been applying it to different parts of the business ever since to try to get some of these really big speed ups.
Okay.
So there's, immense technical challenges here. It's a very, very complex kind of technology that's been made a little bit simpler by tools like TensorFlow and Keras,
Sure.
which are kind of tools that make deep neural network training a little bit easier. But there's a lot of mathematics behind it. There's a lot of kind of core technical topics, and then ultimately it takes a while. You need a lot of computational capacity because it's very expensive to train.
Sure. No, that's quite fascinating to me. Do you maybe want to kind of TensorFlow's the open source Google one, correct?
That's right.
Do you maybe, and then what was the other one you mentioned? I haven't heard of it.
Oh, it's Keras.
Okay.
It's sort of so TensorFlow, I think, has gotten a lot of love, maybe particularly because it is Google,
Sure.
the tool that Google uses internally, and they've open sourced it.
Okay.
So it's probably gotten the most public recognition.
Sure.
Keras is the one that's sort of built on top of that, and the idea is that there are lots of operations in TensorFlow that you do over and over again,
Okay.
but it's a lot of lines of TensorFlow code. So
Okay.
Keras kind of abstracts some of that and makes it a little bit easier for you to write the code. But it sits on top of, or can sit on top of TensorFlow.
Interesting. Okay, very cool. Yeah, no, that's always quite fascinating to me. So, you guys also do kind of a Bitcoin blockchain course. What do you guys kind of cover in that? Because I think that's another kind of hot topic that I think is kind of in the public eye as well lately.
Absolutely. I think one of the things that's really interesting about Bitcoin and blockchain is really that it's not built on any fundamentally difficult topics, right? It's
Sure.
The core technologies to build this have been around since almost the dawn of computing. But it's really putting together these little blocks correctly and understanding, the way I like to talk about it is that it's one half computer science and one half sociology.
Okay, interesting.
And it's really understanding how people use these kind of cryptographic tools, if you will, things like hash functions, and then leverage connecting that and economic incentives to sort of say, like, well, at certain points in time, people have certain pieces of information. They're going to be incentivized to act in certain ways. And because they do, that incentive then gives rise to the behavior that collectively allows the blockchain or Bitcoin to remain stable and be that store of value.
Interesting.
So,
okay.
Yep.
So what types of stuff do you guys kind of cover in the course then?
Yeah, so I think a lot of it is trying to help people. It kind of comes in two parts, right? Like,
Okay.
One is the kind of the core technologies,
Okay.
the core ideas, like things like hash functions, signatures, what does it mean, Merkle trees, those kind of core basic building blocks of,
Right.
of blockchains, blockchain technology and Bitcoin specifically. But then understanding how those pieces come to play, how they interact with the incentives of the people within the system, and how that gives rise to Bitcoin. I mean, one of the interesting things about Bitcoin is that there isn't actually like a Bitcoin. There isn't a computer somewhere that holds your coin.
Sure.
There isn't an actual thing that you can hold in your hand. but like you can with, let's say, a gold coin.
Sure.
The notion of coin is a somewhat abstracted notion. It's this idea that there is this, I don't know, virtual ownership that you can have that in the network cannot be destroyed, and that you can then irrevocably give to someone else, and that you can then use and interpret and hence use as a means of storing value. And it's really about how these things kind of build up to give you this really almost magical behavior on the internet. It's teaching people that I think that this isn't just 100% magic, that the building blocks of this are actually not that hard. And so if they want to sort of really understand what's going on, or sort of ask that, well, why can't you just do X? You'll start to understand what some of those technical constraints are and why it is hard to do. And you may, I think there's a lot of interest from this course from the banking sector, because they understand, right, financial services, that this is certainly a very viable threat to the existing business model, and that this is something they have to understand as an institution.
Sure.
If they're going to be able to meet the challenge.
Yeah, that's interesting that you mentioned that, because like I've always kind of seen, and this is a very oversimplification, but if you just took away kind of paper money and you just had your like online bank account, like, and you almost say that like, okay, like each dollar is kind of like a Bitcoin. I know that's not the correct way, because sometimes like one Bitcoin's worth $10,000 or something. But like if you just took the money in your bank account and that was kind of all you had access to, right? And you just paid people, but it was the same kind of currency globally, like that's a huge deal for them, right? Like if everybody was just like, I'm going to take all my money out of your bank and I'm not going to use your like physical currency, and I'm going to just trade this currency that is one-to-one, even though it's not really one-to-one, but it works the same everywhere on the planet. That's like potentially like a huge thing. We're so far away from that, but like it totally makes sense why they're so scared of that. Is that like, do you understand what I'm trying to get at there?
Yeah, I mean, I think that's right. And that kind of digital disruption is something that banks are fearing, not just from Bitcoin, but even from the technology giants on the other side. There was a study by one of the top 20 consulting firms, right? I forget if it's Bain, McKinsey, or BCG,
sure,
talking about digital disruption within financial services.
Okay.
And one of the things they traced was consumer confidence in the ability of different companies to handle their money. So do you trust, PayPal to handle your money? Do you trust Wells Fargo to handle your money? JP Morgan Chase?
Sure.
What about Apple?
Sure.
What about Google?
Sure.
PayPal that I already mentioned. And what they were seeing is that while you trusted your bank and implicitly other banks that you may not have a relationship with, technology firms were not that far behind. They were actually very close in terms of consumer confidence.
Right.
And the fear from the banks is really that it's not very far between for those two bars to switch, and suddenly consumers will trust technology firms more than existing banks, at which point they have nothing.
Yeah.
Right? I mean, we all know that most of us have a much more pleasant interaction with the kind of large technology companies in terms of, your Apple products or your Gmail or Google search engine. We have a much more positive interaction there than we have with our bank, right?
Sure.
When I use my bank's mobile app, I'm always complaining that there's sort of UX issues.
Yep.
Every time I have to go into a branch, it's this whole wait process.
Yep.
And to get a potentially very inconsistent answer from branch representatives.
Yep.
And it really is that this kind of the business model around the kind of old business model of, hey, our job is just to securely hold your money. That's kind of not going to cut it anymore. People really want to be able to access their money conveniently. They want to be able to use it when they want, on demand. They want basically they want their bank to behave like an app. And what an app is really good at doing is anticipating your preferences and making it very easy for you to do what you want to do. And that fundamentally comes down to the judicious use of data and the correct use of data.
Sure.
So if you think about it, the reason Netflix is so good at telling you what to watch next is because Netflix has studied this problem and looked at the data on this and is able to do that.
Sure.
Even some more mundane things like looking at, banks and digital departments at companies have this whole name for something called digital capture, the idea that, or digital confinement, the idea that they want you to stay on their digital platform. They want you to be on their website or their app because it costs them a lot less to service you that way than when you show up at a branch or call one of their representatives. And they're constantly seeing the fact that you are unable to do what you want, because the consumers want to stay within, at least certainly younger consumers want to make sure that all their transactions are happening digitally.
Yeah.
But they find that the banks are not giving them the capability of doing that, and it creates a lot of frustration when they have to leave and enter the physical world. Banks begin to catch up to this. They're looking at this notion of digital confinement, looking at journeys and seeing how the data about consumer usage can inform them on where people are leaving the digital platform, so they can start spotting the reasons why they're leaving the digital platform and either making it smarter or tweaking the UX to make that more clear so that people stay on. But if you think about it, that's something that these kind of digital first companies have been doing. That's been the bread and butter, right?
Yep.
So they've just gotten very, very good at this, and they've been able to use this data very, very well. And that's giving them a huge competitive advantage in the modern environment in which companies and people, they're in those interactions between the consumer and the company are often happening across the digital medium, whether it be desktop, notebook, tablet, wearable. And when you have that, you need to be a master at this medium. And it's very hard for these large companies, these large legacy non-digital companies, to master that media.
Yeah, it's actually quite interesting. I was reading kind of another article. I know the one you're talking about. There was one that was saying that Starbucks is the most successful kind of digital currency kind of globally because they have so many locations globally. And at first I was kind of like, no, that's kind of stupid. But then I was like, no, it's actually really correct. Sure, I have to put my regular currency into their app, but it works in Canada, it works in Mexico, it works in in the United States, it works in Europe and a handful of other countries on the planet. And if you think about if your bank account your employer put your paycheck into your Starbucks account or your Apple account or your Google account, and you just tapped your phone to pay for things kind of globally, why do you need a bank, right?
Yep.
Because Apple Pay works in a handful of countries already. Google Pay works in a handful of countries, and Starbucks and other. If you just it's an interesting concept, right? We're years out from it if it ever happens, but it got me kind of thinking, right, about the whole space, and I didn't really realize Starbucks is kind of a digital currency, but it very much is, right?
Yeah, look, I think that you're seeing this more and more, and the payment space is kind of heating up because of this. And it's not just, payments, right?
Sure.
They're under attack. Banks are under attack from all sorts of other fronts. So wealth management.
Yeah.
Right. You have the Betterment and Wealth fronts. Incidentally, actually, Betterment hired one of our fellows as their first data scientist, or one of the first data scientists, and he eventually became their chief data scientist, or their head of data science, which is kind of a story that we're always very proud of. But that's another way in which banks are being assaulted digitally. I think with payments, obviously that started with PayPal. It's happening now with Venmo. And I think that there's just the traditional businesses that these banks have occupied. Each line of that business is being attacked from a different digital competitor. And I think they're now quite worried about what to do.
Sure. So I'm curious, though, you guys run a course on kind of data science for business leaders. How does that tie into the conversation we're just kind of having about, people in these businesses worried about some of this data that other companies are kind of have a pretty good jump start on.
Yeah, I think that's exactly, you hit the nail on the head there. What we are seeing is that, especially a lot of these legacy companies, you have a layer of management, kind of line level management, let's say, as well as executive leadership, where they're suddenly waking up to the fears of being disrupted, the fear that they're not doing enough with data to really be able to be a viable business in the 21st century. And so they're all looking at how do I get caught up, not necessarily in a hands-on keyboard kind of way, right? So when I talk about our machine learning course, when I talk about our data science fellowship or the data science online foundations course that we have, those are all hands-on keyboard, practitioner geared, like let's get you to the place where you can become a data scientist. For the manager's course, that's much more, which by the way, we're calling data science for business leaders. That's really focused on people who don't have to necessarily implement these things day in and day out, but who have to understand the concepts and who have to be able to make decisions based on that. So a lot of it is explaining to people, hey, here are the trends that are happening in the industry. Here's how you think about what a data project is, what goes into a successful data project. How do you justify a data project? How do you think about what the metrics ought to be? What are some sort of telltale signs that help you evaluate for good versus great kind of data projects?
Sure.
These are all things that you have to understand as a manager. Right. I think as we've gone through, what we've seen is that there's a lot of interest from different managers who want to be champions for data, but they're not sure how to do that.
Sure.
And they're not sure how to do that specifically within a corporate context. And so one of the things we do is we help them schedule courses around July and August, when a lot of companies are starting to, because right immediately afterwards, a lot of companies are going to be gearing up to do annual budgeting. And so they want to make sure that their key stakeholders understand what how important data is, so that when the bank or whatever the large company is, the enterprise goes to set that agenda for the next year, they appropriately incorporate data and understand the value of data in that budgeting process. And a lot of it goes with explaining to people who want to be data champions, hey, this is how you might think about becoming really data savvy. These are the things you might want to do to promote a greater culture of data literacy within your company. Thinking about how do you find projects that will give you some immediate success, so that you can then go in at the next budgeting cycle and use that success to justify more funding and more headcount and more growth, to really build out an operation that's sustainable, as opposed to kind of a one-off project. It becomes a active, ongoing part of the company.
Sure. No, I think that's great. You guys also offer a few more courses, and we're kind of coming to the end of the show, but I definitely want to kind of quickly mention each of them just to get kind of people thinking about it. So you guys do one in deep learning. Do you maybe want to give a quick overview on that one as well?
Yeah. So, deep learning is obviously a major topic right now. I think I was talking a little bit earlier about how artificial intelligence is often used as a term for deep learning, and that deep learning is really about this kind of neural network type of topics that let people really learn about much more complex situations than they've been able to do before, and are really kind of at the forefront of both academic and kind of industry research on what can be done with machine learning, right? So I think that's the reason we're offering a class on it.
Sure.
Sorry, go ahead.
No, totally. And then you guys do kind of a DevOps course. Do you want to maybe cover that quick? Because I think those people, to actually find a really good DevOps person, you could probably argue might be the one of, if not the most important person on your team, especially if you're a software startup. Is that fair to say?
Yeah, very much. It sounds like you have fought the battles of the
yes, very much so.
startup.
Yes, very much so.
Yeah, look, DevOps is incredibly important. And I think the angle that we take on it is there's a lot of people who kind of understand how to do DevOps for sort of your standard software system.
Yeah.
And we cover that. But we also add in what happens when you want to put in machine learning and deep learning into your system. How do you version your models? How do you keep track of them? How do you test for the correctness of that model? Sure. Right? A unit test is great when you know exactly what the behavior should be. But it gets a little different when you have a model that's just supposed to be smart, right? It's not. There's not,
sure.
not necessarily an easy to write down correct answer. And then how do you get these models up into production? How do you ensure that production equals development? All these things are incredibly important, and they have a lot to do with sort of, I guess, both developer and data scientist productivity and happiness.
Sure.
And they have a lot to do with sort of the reliability of your ultimate product that you ship.
Sure.
It's one thing if you have a bad research environment and your data scientists and researchers are sort of, the system is down 10% of the time because it wasn't built well, and so a tenth of your research budget is kind of thrown away.
Yeah.
But it's quite a different thing when your product when your actual live production site is down a tenth of the time, because it's not going to be 10% of your users who go away. It's going to be all of your users who go away.
That's exactly your point. There is exactly why I would probably argue they're one of, if not the most important person on your team. Because if you're selling a software business, like a subscription SaaS business, if your product's not up online and people can't access it, you're in deep trouble, right?
Yeah.
So
exactly.
That's just because in my experience, I've worked with people that are outstanding in DevOps, and I've worked with people that are not outstanding in DevOps, and you can tell the difference like so fast. It's unbelievable.
Yeah, and I think one of the really exciting technologies there is Kubernetes, and that was also actually a Google technology that we use a lot internally. Right, we are dog fooding this stuff. And because we are keeping up our systems using Kubernetes, but then we figured, this is something that we've got a lot of demand from our clients, corporate training clients, around like how do we productionize.
Sure.
And so that's why we've been offering it.
What is Kubernetes, just for people that don't know?
Kubernetes is it's called orchestration. So I guess maybe the way to explain this is, when you write a web server, or you write a model that does some training, some model that sort of delivers some machine learning and machine intelligence, that's just sort of a little application. But there's a lot that has to do with keeping the application up and running, ensuring that that application is able to talk to your other applications.
Sure.
And that level is called orchestration. Part of it is like constantly restarting it. So applications aren't perfect. Sometimes they die.
Right. When
they die, you basically want a machine that just goes and kicks it up again.
Yeah.
So it restarts, so that you don't have to fire your own engineer to do this, and it's also your website isn't down.
Sure.
So that's a major part of orchestration, and it's also sort of part of this trend towards microservices.
Sure.
So the idea is that instead of building one monolithic app, you break the app up into lots of little microservices that all work together, so that each component is easier to update and maintain. You sort of separate your concerns nicely, and you need something to glue it all together.
Sure.
And that's the layer that Kubernetes provides.
Interesting. And so you guys also offer a course on distributed computing and real-time streaming. They're two separate courses, but I definitely want to kind of just give a quick overview on both of those before we kind of close out the show.
Absolutely. So, with distributed computing and Spark, I think that's the name of the game with big data, right? It's not the data you can fit on your computer. It's the data that you have to fit on a cluster, because it's so big you can't reside on any individual computer. And then so how do you process that data when it's spread out over 1,000 nodes on your 1,000-node cluster. And that's kind of what we talk about as the concepts of parallel computing, distributed computing, as well as sort of tools like Spark and MapReduce to help you solve those problems.
Very cool.
On the real-time streaming side of things, I think that's the other part of big data, right?
Yep.
It's volume, velocity, and variety, and this is the velocity part. Consumers are becoming increasingly impatient. They want these results immediately.
Yep.
And so you have to start training, learning about consumer trends, customers and user trends immediately, put those into production. And that's about real time. It's about streams, I guess, and handling data in a kind of a different paradigm where, you may have a huge data set that you eventually collect, but right now you only have the first 100 megabytes of it. So do what you can now. Oh, and by the way, every second that comes by is another 30 kilobytes of data that you have to then assimilate, update, incorporate into your model, and push out to production.
Sure.
So it's about how do you do this in a way that's kind of robust, faithful to the mathematics, but also doable technically.
Sure. And you guys do that with Amazon, right?
Yeah, that's right.
Yeah,
we have some really great collaborations with Amazon that help us be able to deliver for their customers.
Sure.
And also allow us to sort of do trainings for them.
Sure. That's why like people get so angry sometimes when, the like once every couple of years when like the Amazon Web Services goes down, like half the internet goes down and you can't watch Netflix or, everybody's been there. But we also, I think, relate it to like, if your Netflix movie or TV show doesn't start up instantly, people get annoyed. So I think, those are just real world cases that I think a lot of people have experienced.
Yeah, absolutely.
But Michael, we're at the end of the show. Again, I really, really appreciate you taking the time out of your day to be on the show. But let's close with mentioning where people can get more information about you guys. Yeah.
So if you want to learn more information about the Data Incubator, we're at www.thedataincubator.com. Or you can just Google the Data Incubator, will be the first hit.
Perfect, man. Well, I really appreciate you taking the time in your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day.
You too, Kevin.
Thanks very much. Okay, bye.
Bye.
Thanks for listening. To join the free community, buy some merch, sponsor the show, or sign up for the newsletter, please visit the website at buildingthefutureshow.com. The music for the show is done by Electric Mantra. You can check him out at electricmantra.com and keep building the future.